Hello and welcome to section 1.2. Today we're going to look at measuring and constructing segments. Before we begin, we need to identify a couple terms that you may or may not be familiar with. The first set of terms is going to be what we call a postulate or an axiom. You're going to see that we use these quite a bit throughout geometry, and this is nothing more than a rule that is accepted without having to go through and prove the whole thing. On the other hand, we have what we call a theorem. And a theorem is a rule that can be proved. So the very first postulate that we're going to look at is what we call the ruler postulate. The ruler postulate states that the points on a line can be matched one-to-one with the real numbers. The real number that corresponds to a point is what we call that coordinate point. So if you have 2 points, as you can see like right here at A and B, okay, and let's say on your ruler, if you line those 2 points up, this might line up with the number 4, and we'll say 6. So the coordinates would be 4 and 6, and the points would be A and B. Now if you continue to read farther down here, it says the distance between points A and B can be found by taking the absolute value of the difference. So in other words, if I use the example from above, like up here, if I want to find the length of AB, I would take 6 and subtract 4 from it, and that's going to give me 2. So my distance is 2. So using this information, let's go ahead and look at our first example. Our first example says to measure the length of ST to the nearest tenth of a centimeter. So to go ahead and do this, what we're going to do is I always start out with the point on the left. You can do the right if you choose, but essentially I'm going to take point S here and I'm going to line it up with one of the numbers on this ruler. Now in this case we are using a metric ruler. We are measuring in centimeters here, and if I line S up with the number 2 and I go and I look at letter T here, and I can see that it ends at something around 5.4 centimeters. So if I want to find the distance between S and T, I have to take the absolute value of the difference, or in other words, the absolute value of 5.4 minus 2, and that's going to give me 3.4. So I know the length of line segment ST is going to be 3.4 centimeters. Now, I'd like you to pause the video, take out a ruler, and measure the lengths of each of these line segments to the nearest 1/8 of an inch. We will go over these in class when I return to make sure that you guys are okay with measuring on paper. So we will do that together. We'll go over these solutions when I get back. The next thing we're going to look at is constructing and comparing congruent segments. So in order to construct something in geometry, 2 very basic tools that we'll use quite a bit is what we call a compass, which we have right here. Notice with a compass, you're usually going to have one end that's kind of pointy. Okay, sometimes those can be really sharp, so I do advise you to be kind of careful. And then the other end is going to be a writing utensil. Typically in my class, it's a pencil, unless you put your own writing utensil in there. And then we're going to have a straight edge. Okay, and a straight edge in this case is typically going to be a ruler. I do have inch and metric rulers available for you guys to use. So I'll show you where all that stuff is when I get to class on Wednesday. So to start to get kind of familiar with using a compass and a straight edge, we're going to use these tools to construct a line segment that has the same length as AB. Now, I really want to caution you right now, we will use a compass and a straight edge quite a bit this year, so please take the time to learn how to do this. I will be testing you on this, I will be quizzing you on this, so don't try to just fake it or measure the segment. This is something like a skill that you actually have to know how to do. So in order to construct this line segment and have it be the exact same length as AB, what you're going to do is we're going to use a straight edge to draw a segment that's going to be longer than segment AB. And you can see that we have done this down here. So we're going to start a segment. Now typically I will start my segment right below and have it even with A in this case. and we want it to be longer than AB. And we're going to label that starting point C in this case. You can label it whatever you want to on your own when you're doing your homework, but for right now we're going to label that as segment or point C. Then our second step is going to be to construct or measure rather the length of AB. So what we're going to do is we're going to put the pointy end of your compass on point A, and then you're going to widen it out so that your pencil mark could draw a line through point B. Once you have that distance set, we're going to go ahead and move that compass from point A down to point C, and then we're going to draw a segment. Just a little tiny kind of like dash or tick mark that goes through this line segment down below. So you can see when we do that, we now create a new point that we're going to label as D. So now what we can conclude is that the line segment AB is going to be the same as line segment CD. Go ahead and pause the video, take a quick second, and make sure that you can recreate these two line segments here. Now that we've just learned how to create two line segments that are the same length, we're going to go ahead and throw in a new term to you. And that new term is going to be what we call congruent, okay? So line segments that have the same length are going to be called congruent segments. So in that previous example, we saw that segment AB is congruent to line segment CD. Now notice, okay, here we have an equal sign. This is saying that the two lengths are equal. If we use the phrase congruent, okay, congruent has an equal sign, but it also has a little squiggly at the top, and you can also see it down here if that's easier for you to view on your screen. But the congruent symbol is an equal sign with that little squiggly line here at the top, and that just means that they're congruent or the lengths are the same. You will be seeing the congruent symbol quite a bit this year, so just make sure that you're familiar with what it means. So now let's use this information and we'll go ahead and look at example 2. For example 2, it says plot the points J, which is -3, 4, K, which has a coordinate point 2, 4, L, which is 1, 3, and M, which is 1, -2, on a coordinate plane. Then what we want to do is we want to determine whether JK and LM are congruent. So here you can see that I've got the points plotted on my coordinate plane. I also have them labeled. Now, you don't have to label it like the -3, 4, but you should at a very minimum have JK, L, and M all labeled. So now to determine whether or not JK and LM are congruent, I first have to find the length of JK. And I'm going to do that by taking the absolute value of the difference of my x coordinates. So in this case, I have 2 minus a -3. And when I simplify this, I have the absolute value of 2 minus a negative. That really becomes 2 plus 3. Or I have the absolute value of 5, which gives me a distance of 5. I'm then going to go ahead and do the same thing with LM. And again, because LM is a vertical line, or this line right here, I'm going to compare or essentially find the difference of their y coordinates. So in this case, I have the absolute value of a -2 minus 3. So when I find the absolute value of that, I have the absolute value of -2 minus 3 is a -5. And the absolute value is going to give me a +5. So I can see that these two numbers here are the same. And that tells me then that JK is going to be congruent to LM. And again, JK being congruent to LM just means that they're the same length. Now when we were finding those absolute values of the distance here, or the differences, we were actually using the ruler postulates. Please pause the video and try this example on your own. For this example, you can see that I've plotted A, B, C, and D. I've connected segment AB and segment CD. Now I have to prove or see if they're actually congruent. So to do that, I'm going to find the absolute values of their differences. So for AB, I end up with the absolute value of 3 minus a negative 2, or the absolute value of 5, which gives me 5. For CD, I end up with the absolute value of 2 minus a negative 2, and 2 minus a negative 2 is going to give me the absolute value of 4, which is 4. So 5 is not equal to 4, therefore these are not congruent segments. Now the last thing we're going to look at in section 1.2 is using what we call the segment addition postulate. And the segment addition postulate just tells us that when you have 3 points that are collinear, and remember collinear means that they lie in the same line, then we can say that one point is going to be between the other two. So when you look at this example here, we can see that point B is going to be in between A and C. When we look at this example over here on the right though, E is not on the same line as DF, therefore E cannot be in between D and F because they're not on the same line. So we would not be able to use this segment addition postulate with point E, but we could with point B. So the segment addition postulate states that if you have some point, in this case B, that falls in between A and C, then we can take the two smaller distances, so the distance from A to B and the distance from B to C, and if I add those two up, that's going to give us the total distance from A to C. So for example 3, it says using the segment addition postulate, we want to find DF. So here I want to find the length from D to F, and I can do that by taking 23 and adding that to 35. And when I add those two together, I get a total distance of 58 units. Likewise, for part B, I know that my total distance is 36. So I'll say 36 is going to equal the distance from F to G, which is 21, plus the distance from G to H. Or that tells me that GH then is going to equal 15 units. Please pause this video and try this example on your own. For this example, we're to find the distance from X to Z. So here I want XZ, which is this distance. Now in order to find that, I can see that I have the distance from X to Y and Y to Z. X, Y, and Z are all collinear, so I know that I can add 23 to 50 to get my distance of XZ. And when I do that, I get a distance of 73 units. Now for part B, it says in the diagram, WY is 30, so I will go ahead and label this as 30. And it wants to know if we can use this segment addition postulate to find the distance between the points W and Z. Well, W and Z are actually right here and right here. And we were given the distance, or the distance from W to Y, which is right here. So W, Y, and Z are not collinear, therefore we cannot use the segment addition postulate, and we can't find that distance in between W and Z. Now one thing to kind of note, in our notes throughout the year, we're going to write the word point a lot. So I usually shorthand that as PT. And you may want to do that too if you find yourself having to write it quite a bit as well. Please let me know if you have any other questions on notations like that throughout class. The final example for today is example 4, and it says the cities shown on the map lie approximately in a straight line. We want to find the distance from Albuquerque, New Mexico to Provo, Utah. So you can see if I were to go through and label these, which they are. So Provo is point P, and Albuquerque is point A, and then we are given Carlsbad is point C. We only know the distance from Provo to Carlsbad and Albuquerque to Carlsbad. So in order to find the total distance from Provo to Albuquerque, we are going to have to use this segment addition postulate. So essentially what we know is we know that PC is equal to PA plus AC, and if I plug in the numbers I know that 680 is going to equal 231 plus PA. If I solve for PA, we find out that it's actually going to be 388 miles. So using the segment addition postulate, we were able to conclude or figure out this distance right here. Please let me know if you have any questions. Otherwise, I will see you guys in class on Wednesday. Have a great day.